Okay, now we're going to focus a little bit more on the unit circle. This is day 2 or lesson 3.3. So last class we talked about how this was 0 degrees or 0 pi. And this was 30 degrees or pi over 6. This is 45 degrees or pi over 4. This is 60 degrees or pi over 3. And then this is 90 degrees or pi over 2. And then this is on the unit circle, so our radius is 1, which makes this ordered pair 1, 0, and this ordered pair up here is 0, 1. And then we talked about how we can use our 30, 60, 90 rules, and our 45, 45, 90 rules, and our 30, 60, 90 rules again to get these ordered pairs for each of these reference angles. So the 30-degree angle is square root of 3 over 2. And the y value is 1/2. 45, 45, this is square root of 2 over 2. And then for the 60-degree angle, this is 1/2, and this is square root of 3 over 2. Okay, so we talked about all of that last set of notes. And then they want us to evaluate the 6 trig functions for sine of pi, or for pi over 6. So we're going to do sine of pi over 6. We're going to do cosine of pi over 6. We're going to do tangent of pi over 6. So remember, when we have an ordered pair on the unit circle, x, y, the x value corresponds to cosine and the y value corresponds to sine. So if I'm looking at pi over 6, I'm looking at this ordered pair right here. So the sine is 1/2. The cosine is square root of 3 over 2. Tangent, remember, we got tangent of theta. It's the same thing as y over x. So it would be 1/2 divided by the square root of 3 over 2, which ends up being 1/2 times 2 over square root of 3. So it's 1 over square root of 3, which rationalized equals square root of 3 over 3. And then cosecant of pi over 6, that's the reciprocal of sine, so it'll be 2. Secant of pi over 6 is going to be 2 over square root of 3, which will end up rationalizing to be 2 square root of 3 over 3. And then cotangent of pi over 6, I'm going to think of it as this right here before it got rationalized and flip that fraction because it's a reciprocal, and it would be the square root of 3. All right, let's do another example. Okay, for this one, you have to think about the fact that it's a quadrantal, and it's going to end up right here. This is where pi is, and it's on the unit circle, which, if you'll recall, that ordered pair right there is -1, 0. So, remembering our rules, sine is the y value, so it's 0. Cosine is the x value, so it's -1. Tangent is the y over x, so it's going to be 0 over 1, which is the same thing as 0. And then cosecant of pi equals the reciprocal of sine. So, this is right here understood to be 0 over 1, so the reciprocal will be 1 over 0. You're not allowed to divide by 0, so this is undefined because of that. Secant of pi is the reciprocal of cosine, so it'll be -1. And then cotangent of pi would be 1 over 0, which again is undefined. Okay, so when we're thinking about things that are undefined, what I want you to think about is how we talked about sine of an angle. It's the opposite. If you're thinking about a reference angle right here, and we've got our y over here and our x here and our radius right here. Sine is the opposite over hypotenuse, so it's y over r. Cosine is the adjacent over hypotenuse, so it's x over r. Tangent is the opposite over adjacent, so y over x. And then cosecant is the reciprocal of sine, so it's r over y. Secant is a reciprocal of cosine, so it's r over x. And then cotangent is a reciprocal of tangent, so it's x over y. So if we're thinking about what can be undefined, This can't be undefined and this can't be undefined because the radius will never equal 0. And the only time you're undefined is when the radius is 0. Tangent and secant will be undefined in the same places because they're undefined when x is 0. Whereas this cosecant and the cotangent are going to be undefined in the same places because they'll be undefined where the y's are 0. So that's kind of what we're looking at here. We've got the cotangent and the cosecant undefined in the same places because the y value was 0 there. All right, let's do another example. We got 5 pi over 4. So remember that this is pi. With a denominator of 4, we would write this as 4 pi over 4. Well, halfway would be 2 pi over 4 here, or 6 pi over 4 here. So 5 pi over 4 is right here. All right, that's a 45, 45, 90 triangle. Whenever you have a pi over 4, that the reference angle pi over 4 is always going to be a 45-degree reference angle. So incidentally, like anytime, I didn't write that very well, sorry. Pi over 4 is a 45-degree reference angle. Any pi over 6 is a 30-degree reference angle, and any pi over 3 is a 60-degree reference angle. So we should be thinking about our 45, 45, 90 rules, which means that your ordered pair will be square root of 2 over 2 and square root of 2 over 2. In this quadrant, they're both negative. And so that should help me find my 6 trig functions. Or you can remember your rules for a 45, 45, 90 triangle, where this is 1. In this quadrant, it's negative. This side's 1. And again, it's negative in this quadrant. And this is square root of 2. All right, so sine of 5 pi over 4 is going to be a negative square root of 2 over 2. Matches that y value right there. Cosine of 5 pi over 4 would also be negative square root of 2 over 2. It matches the x value. Tangent of 5 pi over 4, you're doing the same thing over itself, or you're doing opposite over adjacent. So it's going to end up being a positive 1. Cosecant of 5 pi over 4. So it's a reciprocal of sine, which means it's hypotenuse over opposite, which will be a negative square root of 2. Or that's what if I were to flip this fraction here, it would be 2 over negative square root of 2, which you multiply by square root of 2 over square root of 2. And you get 2 square root of 2 over 2. It's negative. Those cancel, so you're left with negative square root of 2, which is what we had right here. Secant of 5 pi over 4 will also be a negative square root of 2. And then cotangent will be, cotangent will be a positive 1. So things you should also think about is the fact that all of the trig functions are positive in the first quadrant. Sine is positive here. Tangent and its reciprocal cotangent are positive there. And then cosine is positive here. So we're looking at the third quadrant, which means the only thing that should be positive are tangent and its reciprocal cotangent. Everything else should be negative there. Okay, next we're going to look at the sine of negative pi over 3. So this is pi, and if we're going in the negative direction, then this is actually negative pi. But with the denominator of 3, it would be negative 3 pi over 3. So well, actually, if this is 0, a negative pi over 3 is just going to be right here. And so any pi over 3 is a 60-degree reference angle, so you can use those rules. If you've got the unit circle memorized, then you can just think about this 60-degree angle right here on the unit circle, which had the ordered pair 1 half and then square root of 3 over 2, which this one's going to have the same ordered pair. The only difference is in this quadrant, the y's are negative. So if we're looking at sine negative pi over 3, it's going to just be a negative square root of 3 over 2. That's one way to do it. Or remember your 30, 60, 90 rules. The side across from 60 is square root of 3. In this quadrant, it's negative. The sine across from 30 is 1. And then your hypotenuse is 2. So if you do opposite over hypotenuse, it ends up being that negative square root of 3 over 2. 240 is in this quadrant here. This is 180, so 240 is right here. You always make your reference angle with the closest x-axis, You've gone 60 degrees past 180, so you're using your 30, 60, 90 rules, or again, you're using these rules right here because this was for a 60-degree angle. So we're in the third quadrant, which means my x's and y's are negative, so this is going to be a negative value. Cosine uses the x, and so it's going to be a negative 1/2. Or using our 30, 60, 90 triangle, the side across from 30 is 1. It's negative in that quadrant. The side across from 60 is the square root of 3. It's negative in that quadrant. And then this is 2. So cosine is adjacent over hypotenuse, which is that negative 1/2. All right, tangent 3 pi over 2. You know, when we're counting, this is pi. This is halfway at pi over 2. So 3 pi over 2 is going to be right here. All right, so it's a quadrantal, which means it uses that ordered pair, 0, -1. Tangent, remember, is y over x, so it's -1 over 0, which is undefined. All right, sine of 4 pi over 3. This is pi, which is the same thing as 3 pi over 3. So 4 pi over 3 is right here, which is a pi over 3 reference angle, or we can think of it as 60 degrees. So you can use your 30, 60, 90 rules that we were just talking about a while ago. Over here, the 60-degree reference angle has an ordered pair right here of 1/2 square root of 3 over 2. We're doing sine, so it's the y value, so it's going to be square root of 3 over 2. In this quadrant, though, the y values are negative, so that should be my answer. Or using my 30, 60, 90 rules. This is a negative square root of 3. This is a -1, and this is 2. So doing opposite over hypotenuse would be negative square root of 3 over 2. 5 pi over 3 also uses this 60-degree reference angle. So cosine's the x value, which means it'll be 1/2. We just need to think about what quadrant it's in. This is pi. This is 2 pi. Pi is 3 pi over 3 with that denominator of 3. 2 pi would be 6 pi over 3. So 5 pi over 3 is going to be right here. Well, in this quadrant, the x's are positive and the y's are negative, and so it's going to be a positive 1/2. Again, it's a 60-degree reference angle. So side across from 60 is square root of 3, side across from 30 is 1, and then this is 2. So you'll use the adjacent and the hypotenuse to get that 1/2. Tangent of 315 degrees is right here. That's 45 degrees away from 360. And so on our unit circle, we can use our 45, 45, 90 rules, which says that this is square root of 2 over 2, and this is square root of 2 over 2. In this quadrant, the x's and the y's are negative, so this is negative square root of 2 over 2, and this is a positive square root of 2 over 2. And so tangent is y over x, and so you're basically, if you use the normal 45, 45, 90 rules, this is -1, 1, and this is square root of 2. So you end up with -1 over 1, which is -1. Or you can do the y over the x, which will be 1, and then in this quadrant, the y's are negative, and so it's -1. Okay, on this one, we want to know what degrees would sine of theta equal 1/2. Well, that's the opposite over the hypotenuse, if you want to think about it like that. And you're looking for where it's a positive value. Well, that would be where the y, which is the opposite side over the radius, so where the y's are positive, because the radius is always positive. Well, that's going to happen here and here, where you get an opposite side of 1 and a hypotenuse of 2. Well, that would make this square root of 3. That would make this negative square root of 3. But no matter what, you have a 30-degree reference angle. And so in this first quadrant, it's 30 degrees. Over here in this quadrant, that 30-degree reference angle, it belongs to the angle that's 150 degrees. And we get that by doing 180 minus this 30 to get that terminal side right there is 150. So those angles are going to give me, if I take the sine of each of those angles, I'll get it 1/2. Now, normally we'll tell you we only want angles on this domain. And so that's why you would only give me those two. But if we didn't say that, if we never gave you this, then we would have to just keep adding 360 to get coterminal angles. So 360 plus 30 tells me a coterminal angle would be 390 degrees. 360 plus that 150 gives me 510 degrees. I could have subtracted 360, so a negative 330 degrees. Or, let's see, we get a negative 210 degrees. All of these are also coterminal angles that are, when you take the sine of them, you're going to get 1/2. So what radians would tangent of theta be undefined? So remember, tangent of theta equals y over x, and it's undefined whenever x equals 0. So places where x equals 0 are here at 0, 1, and here at 0, negative 1. And on the unit circle, that's at pi over 2 and 3 pi over 2. Okay, here we have the domain and period of a sine function and cosine function. So domain would be here to here. So that means x right here, where this is going to be on the unit circle. So that means that my radius right here is 1. So x is between negative 1 and 1. Well, x's go with the cosine. So that means that cosine of a reference angle is going to be between negative 1 and 1. So what that means is when I take the cosine of an angle, it has to be somewhere between negative 1 and 1. And then right here represents the range. And from here to here, that's going to be between negative 1 and 1. And then remember that y goes with the sine, so sine of theta is between negative 1 and 1 as well. Okay, so another thing I want you to think about is the fact that these functions are periodic, which means that as you travel around the unit circle, you're going to have multiple places where the sine or cosine or the tangent have the same values as you go around here. So kind of think about a coterminal angle. So coterminal angles, like the cosine, if I took the cosine of theta, it's going to give me the same value as cosine of theta plus 2 pi, because every time you add 2 pi, you end up in the same location. I mean, if we've got an angle that's right here, that's the same angle as this one right here after you've gone around the circle multiple times, because they have the same terminal side. Now, that means we can add and subtract 2 pi over and over and over again. So we're going to put 2 pi in right here, where n is an integer. So we're able to add as many 2 pi's to that theta as we want and get the same exact value. Sine of theta is the same thing as sine of theta plus 2 pi n as well. All right, another thing I want you to think about is the fact that we have trig functions that are even and odd. So the only ones that are even are cosine and its reciprocal secant. Back whenever we were first talking this year, we talked about even and odd functions. Like here's an even function. I know that it's even because it reflects over the y-axis. So what that means is if you took a point right here, I know its y value is going to be 4 if the x value is 2. But if the x value is negative 2, I still have a y value 4. So what that means is that when I plug in a negative x, I get the same value for y as I got before. So if you think about like a 30-degree angle, you know, this is 1, this is square root of 3, and this is 2. If I did that 30-degree angle, if I made it negative, so this is 2, this is a negative square root of 3, the cosine will use this same x value, which stayed positive. So that means that cosine of 30 will equal the cosine of negative 30. Now, if it's an odd function, which all the other trig functions are, that's not the case. So kind of think of an odd function, like a linear function. If I had 3 here, the y value would be 3. And so if I change signs for the x, if I looked at -3, the y value is also -3. So it changes signs as well. So let's think about that. So we have that same 30-degree angle right here. This is 1, this is square root of 3, and this is 2. A negative angle in this quadrant would make this a -1, and this 2. So the sign would go from a positive 1/2 to a negative 1/2. So the sine of a negative t will be equal to a negative sine of t. And that happens for all of these other trig functions. Okay, just a few more. We've got 13 pi over 6. This is pi, which is 6 pi over 6. This is 2 pi, which is the same thing as 12 pi over 6. So 13 pi over 6 will be a full circle past 12 pi over 6, another pi over 6 past that. So it's going to have a pi over 6 reference angle, which pi over 6 uses the ordered pair, square root of 3 over 2, 1/2. And so sine is the y value, so it's going to be 1/2. Or you can use your 30, 60, 90 rules, because pi over 6 is 30. This is 1, this is 2, this is square root of 3, and sine uses opposite over hypotenuse. Negative, or cosine negative 7 pi over 2. We're going in the negative direction. So this is negative pi over 2, this is negative pi, this is a negative 3 pi over 2, and this is a negative 2 pi, which is a negative 4 pi over 2. Keep counting, so this is a negative 5 pi over 2, this is a negative 6 pi over 2, and this is a negative 7 pi over 2. So negative 7 pi over 2 is right here, where the ordered pair is at 0, -1. Oops, 0, -1. So the cosine is the x value, which means it's just 0. All right, sine of t equals 4/5. So it's a positive 4/5, which means that, it would work if it were in quadrant 1. So if this is t right here, and we're saying that the opposite side is 4 and the hypotenuse is 5, if I did the sine of a negative of that same angle, it would be in this quadrant, where now the y's are a -4 and the x, or the hypotenuse is 5. So sine of t equals 4/5 means that sine of negative t will equal a negative 4/5. It just changes signs, and that's because it's an odd function. All right, y'all, that's it for those notes. Thanks.